Great. Thank you, Lakshmi. Good morning, guys. Rahul, Ganesh, and rest. Sorry about the delay. We'll get started here. Just give me one moment while I share the screen. There you go. Here we go. Okay. Bring this up. Today, we'll get started with Google platform, guys, Google Cloud. In the coming up days, I will revisit the Kubernetes and I will give you the touch of Elastic Search. There are a few labs that I was in the middle, and I think that's when we stop. So we'll continue them during the coming up days. And hopefully by tomorrow, I may also get started with a little bit of Openstack. So this week, I will continue with a little bit of Google Cloud Platform and also the Openstack is okay. So just a quick update on that. And let's continue. In the meantime, Rahul, if you can get ready with your Google Cloud, and you also have a Openstack access, you should be able to get into, right, Rahul, from your thing?
Yeah, but for the OpenStack, I need to check once because I haven't logged in last 2 months. So okay. I will check and I will log in. But today, do we require that OpenStack?
No. Today we don't need. Probably tomorrow, day after tomorrow, I may get onto the lab part of it and things like that. You may just want to kind of just log into it and get ready and things.
Okay.
Just giving you a heads up today.
Okay. But sir, for this Google account, sir told to Lakshmi ma'am that she will provide that GCP accounts for the training purpose, because sir told us that they were agreed on that we will provide AWS, OpenStack, Azure Infra, and this GCP Infra will be provided by her. As sir told us this.
GCP Infra, actually, I looked at the labs outside even. I mean, everybody is using the free accounts for learning and training purposes, Rahul. I had a discussion with Lakshmi, also about this one. I mean, at that time, I took it for granted GCP free account should be okay. So that's why we may have missed digging deep into it and things like that. I didn't think that there would be any problem using the free accounts from your side. But I will have another look and also see what I can do from my side, Rahul. Okay.
Okay.
Your free account is not yet expired, right? The free credits and things like that.
No, sir.
Okay, so we'll play around a little bit with that today, tomorrow, and the coming up days until that is done. Once that is done, we can open a temporary Gmail account and try to use the console from there. Okay, so this week we'll get started with the Google Cloud Platform, guys. The footprint again, the cloud computing, all those concepts you guys are already familiar and things like that. So I will not go into the basic level details of cloud computing and things like that. We briefly discussed here and there in the earlier days and so on. So we'll directly go into slightly detailed topics and so on. A rough idea of the Google Cloud Platform or the footprint, where are all the data centers and things like that. Ideally, they have tens and tens of data centers around the world, around different continents. And this is a quick high level look at it. At a slightly low level, the Google Cloud also something similar to the OpenStack, where the primary components are the compute, storage, and the network. And these are the things we'll try to dig a little bit deep and try to understand. They are the basic foundations. The compute, storage, and network are the basic, or we can think of them as the foundation of the foundational services of the Google Cloud, on top of which different kinds of other services have been built. The database, the data and analytics, AI and machine learning. That is where today the most of the money seems to be. And we also have the concepts of private cloud, hybrid cloud, and multi-cloud in large enterprises. API management, almost all these services, just like in Openstack, you might be already familiar with a little bit of Openstack where we can access all these services using APIs and things like that. Even in Google Cloud, these services can be accessed by the APIs, and we'll try to have a quick look at them in the coming up days. We can also migrate from different clouds, AWS cloud or any other kind of cloud, IBM cloud to GCP. So the tools are already built into it. The security and the DevOps tools. Security is, in other words, that's another feature or functionality of the cloud where all the resources are secure. We can also perform the DevOps tools such as the Docker, the Kubernetes, and the CI/CD stuff in GCP. So ideally, if we have an idea of what is Docker, what is Kubernetes, the platform is different, but we will be performing the similar kinds of operations on that we have performed in Docker and Kubernetes in here is what it is. So slightly from an ops level or from a developer point of view, the commands at a Docker or a Kubernetes level will not change. In other words, 90 to 95% of those commands we will be using here. But a 5% of difference will be there at a GCP syntax versus the AWS syntax, which is what we will see and we'll try to understand, okay? Here are some of the main compute services or the most important compute services. The compute engine, app engine, Kubernetes engine, container registry, and cloud functions. These are slightly at a high level. We'll try to get a brief look at each of these things in a moment. Then coming to the storage and the database, the Google Cloud Storage, something similar to your Amazon S3. Cloud Big Data Table, that is something similar to the NoSQL, the HBase world, the what do we say? Not only SQL world is what it is also referred as. Then we have the Cloud Data Store, which is acting like a data warehouse, and Cloud SQL, which is nothing but the SQL Server or the Oracle database. Cloud Spanner is also Cloud Spanner is a data warehouse solution. We'll try to talk about that in a moment, guys. So just bear with me. And then the persistent disk is the additional volumes and things like that that we generally attach to our cloud based on the instances and the virtual machines that we open. So a little bit of theory today before we get on to a lab test, just bear with me. Here is the networking services, the virtual network, load balancers, the cloud CDNs, the CDNs content, what is that? Content defined networking, software defined networking, and what is this? Give me a moment, I'm trying, just missing a word here. Interconnect and DNS, again, we'll talk about these things in a moment. And these are the high level security services. These are the machine learning. This is where all the money is today. And then the development tools and things like that. These are some of the management tools and other kinds of services, guys. Okay, if we dig a little bit deep into them, those are slightly at a high level, which we'll briefly discuss. GCP has a global footprint spanning all the continents. It includes the core infrastructures, database, analytics, AI, and more. In other words, there are different, any kinds of services that AWS that we generally find will also be provided in GCP. AWS is a little bit more mature because they have been in the market for a slightly longer time or a period than the GCP. But ideally, GCP will provide anything and everything that AWS is trying to provide because they're their competitors, guys. Okay, so most of the services that you might be seeing are probably used with a different kind of name with slightly different terminology, and the method and the procedure of how we orient ourselves in the application will be slightly different, guys. The platform has over 100 services spanning IaaS, PaaS. Again, we briefly discussed infrastructure as service, platform as service, and software as service. There are different kinds of services there. So we have already opened the free tier account. We get about $300 free for the first one. And so we can create the virtual machines, app engine instances, and the publish and subscription topics and storage buckets. Storage buckets are similar to our S3 buckets. So we have the hierarchy of resources, projects, folders, and organizations. So here is a quick look. An organization has multiple folders, and a folder may have multiple projects, and each project may have multiple resources. So here is a quick snapshot of how it looks like. Different folders and different kinds of projects and so on. So on the top, .com becomes the organization. That there could be your own nscat.com and things like that. Under that, we are creating different folders. So development, production, test are like the folders, and each folder may have multiple projects is what it is, guys, okay? So resources belong to a project. So first we should have a project, then we try to create the users, then we try to create the roles, assign and the roles to different users and so on, similar to the OpenStack stuff if you're slightly familiar with that part of it. So project represents a billable unit. So anything is billable, and for us it becomes, since we are using the free credit, we will not be billed until the first $300. And folders provide logical grouping. So in other words, all the development stuff are generally plugged into one folder. Similarly, all the production resources and the testing resources are plugged into one folder, guys, okay? An organization is a top level entity. An organization is like basically a client. A particular company may work with multiple customers, multiple clients and things like that. NSC may be one client for a company. They may also have Walmart or maybe Target. So for each of them, they will create a different organization. And under each organization, they maintain the specific documents and other kinds of resources related to it. Just like AWS, we also, in Google Cloud, we can use the web console. We also have the Cloud Shell access and mobile app. Okay, unless it is really necessary, we don't really go and do mobile apps because these are slightly heavyweight stuff, unless you are quickly checking some status and dashboard related stuffs. REST API is a programmatic way of accessing the different resources of Google Cloud. Is what it is, guys, okay? Then the GCP shell, we'll see in a moment. I think we may have already looked at it. Have we got into the GCP shell, Rahul, last time?
Yes, we have used that GCP shell and logged into that server,
okay,
which we have created.
Okay, thank you. Sorry about that. An interactive shell environment for GCP. So it's a interactive shell accessible from any web browser. Comes preloaded with the IDE, G-Cloud, SDK, and other tools. In other words, generally we need to, if you're using a PowerShell or maybe a command prompt, we need to install the G-Cloud, which is not really complex or anything, but the inbuilt shell has already the G-Cloud SDK already installed, where we can issue the G-Cloud commands, the Google Cloud commands. And behind the scenes, the Google Cloud packages has its own set of packages and things like that with all the necessary components, which we'll try to understand in a bit, guys, okay? So it is based on a GCE. GCE is Google Compute Engine. And there's a subtle difference between the Google Compute Engine and the Google App Engine, which we'll try to look at. It provides 5 GB of persistent storage. So in other words, short and sweet, 5 GB is the free storage they're giving. It also gives us the built-in web preview. So we can also look at it from a website or in the browser, guys, as simple as that. So there it is. Ideally, we create a first project, then we are generally looking at the project and the building, the VM instances, instance groups. This is where we create different kinds of VMs. This is something like AWS console. We call this as G-Cloud console. You may have already looked at it. So there is the first project and each project. So if you're looking at here, this is the Google Cloud Shell. And each project will have project ID associated with it, is what we are looking at, guys, okay? And let's see. Come back here. Okay, a little bit in depth into these things. This up. Sharing it. Okay. Again, we get a free $300 credit. We have different kinds of assets, organizations, folders, and so on. It is accessed through the console, Cloud Shell, SDK, and mobile app. We discussed about it. Cloud Shell is a powerful environment available within the browser. It is a easier way to get into the Google Cloud without really installing any heavyweight stuff into our own computers and client machines, guys. Okay. So what is GCP? Compute services are a critical component of the cloud. In other words, compute is one of the most important. It is the heart of the cloud. The storage can be thought of as the brain. The networking is nothing but the nerves of the cloud is what we can think. So the compute, storage, and the networking are the three foundational aspects of any cloud. Code is deployed and executed in one of the compute services, which means generally we write our .NET code, maybe a Python code, or maybe a development code. We develop our own code, and then we deploy it into the compute. That's where the Google Compute is used, where you're developing your own application based on your requirements, and you try to deploy it and configure it based on the requirements, guys. Okay. So GCP offers a wide range of compute choices: App Engine, Compute Engine, Kubernetes Engine, Cloud Functions. So let's see, here is App Engine, one of the first compute services from the Google platform as service. So fully managed platform for deploying web apps at scale. So it is used for deploying the web applications is what it means. Supports multiple languages, which is Python, Java, .NET, and so on. App Engine is available in 2 environments, again, standard, flexible. So again, the pricing will be different. We'll try to look at that. Applications deployed in standard environment run in a sandbox. Sandbox is a environment in which like something similar to Docker, but not exactly. So in other words, it's an isolated environment where we can test some of our stuff and things like that before we actually decide to go and deploy in the production and so on. Flexible environment uses Docker containers to deploy and scale apps. So again, Docker comes into the picture, and we use the Dockers and the containers, Kubernetes to orchestrate the containers and so on, guys. Okay. So Compute Engine enables Linux and Windows VMs. In other words, we can create Linux, we can create Windows machines. VMs are based on the machine types. Again, the flavor of a machine will be different based on how many CPUs and RAMs. Persistence is available through standard SSD disks. So in other words, again, persistence is nothing but saving the data to a disk, and we have the SSD disks. VMs are charged a minimum of 1 minute and 1 second increments after that. So in other words, the virtual machines will be charged. Sustained use discounts are offered for running VMs for a significant portion of the billing month. In other words, generally, when we take any of these resources, when we run them for long term, 1 year or 3 years, they have some special discounts rather than taking them for smaller amounts of time. So in other words, they're indirectly encouraging the companies or the enterprises to take the resources for a slightly longer period, such as 1 year or 3 years, so that and they can get the discounts and so on, guys. Okay. Kubernetes Engine, we spent some good amount of time. It's a managed environment for deploying containerized applications managed by Kubernetes. In other words, Kubernetes, if you recall, is an orchestration engine. Docker creates them, and Kubernetes is playing around. It is used for deploying different kinds of containers in a different way. GKE provisions worker nodes as GCE VM. So everything is a VM behind the scenes. Node pools enable mixing and matching different VM configurations. So short and sweet, if you still recall the Kubernetes concepts, node pools is nothing but a group of nodes or group of virtual machines can be treated as nodes. Node pools. A pool of nodes is what is node pool. The service is tightly integrated with GCP resources such as networking, storage, and monitoring, which means the Kubernetes is actually a solution from the Google, and it is actually tightly integrated, means it's automatically taking care of many of the manual stuff that we have to take care from networking, storage, and monitoring perspective, is what it means, guys. Okay. Automatic scaling, upgrades, and node auto repair are some of the unique features of Google Kubernetes Engine. So again, it's an orchestrator. It is constantly, we can configure it in such a way. If you still recall the master and the worker nodes architecture, the master is constantly monitoring all the workers. If any of the containers go down, the health is reported to the master. The master will automatically bring up on another one. So that is the fault tolerance, and based on the replication factor that we generally specify, the master is generally taking care of making sure the required number of containers are up and running and so on. So all those things are built into it, and we have looked into the Kubernetes aspect of it, guys. I'm just giving you a quick brief idea. Then the cloud functions. Cloud functions is a serverless execution environment for building and connecting cloud services. So this is nothing but similar to the Lambda functions and things like that. And we'll try to actually run an example of this one using Python in the coming up days. So they're serverless. The advantages, we don't have to rent a server and pay the server while we are not using. The cloud itself is pay as you go, and where we are saving a lot of money. The cloud functions of the Lambda functions save us even more money, where when we need to run very discrete functionality at specific periods of time or only at limited times, we could make use of the cloud functions. And as a result of that, we are saving all the costs that we would otherwise incur taking a server or taking a dedicated server and paying for it, guys. Okay. So cloud functions, again, we can write them in JavaScript, Python, Go, and what other languages also. GCP events fire a cloud function through a trigger. So it's also possible to hook up the triggers, run a particular Lambda or a cloud function. When a certain event happens, you run this Lambda. If it doesn't happen, then you don't do anything. It's also possible to configure them. An example event includes adding an object to a storage bucket. So whenever somebody uploads a particular kind of an image, we could probably have another Lambda function which is reading this image, trigger a Lambda function which will read this image, and it will try to detect or predict whether it's a cat or a dog. Maybe it's a indication if it's maybe a stock data. It will read this data and it will try to make a prediction whether, hey, it looks like this stock is going to go up or maybe go down and things like that. Those triggers can be connected using the cloud functions, guys. Okay. So behind the scenes, it also saves some good amount of money for the companies. Trigger connects the event to the function. So let's say, so back to the Google Cloud platform. And I think this is where I think we may have created this one. If you're logged in, can you just share your screen? We'll have a few steps here, Rahul.
Yeah.
Okay. Have you stopped that? Do you still have the VM instance or?
No, sir.
I think you need to go into the, let's say, compute, okay, instances, yeah. VM instances. Okay, you still have 77 days remaining, okay. Okay, so I think you deleted. Let's quickly create an instance, Rahul. Instance form. Yeah, you can leave that as it is.
Naveen sir, Ganesh this side. I think Sumit is in waiting. Check.
Hello, Ganesh.
Sumit is in waiting, sir. Can you add him?
Oh, okay. Is there something like that? Just one moment, I'm seeing how to add him. I don't see anything like a waiting room here. There is nothing like a waiting room configured here. I don't know why he's waiting. Ganesh?
Okay, sir, I will check with him. Give me a Thank you.
I think from what I recall, we have chosen the N1 standard one. Have you chosen the N1 standard? Yeah.
Yeah, M1 F1 micro.
F1 micro. And I think last time we chose Ubuntu 18.0.4. That comes in the boot disk. Display device, display container, bootable disk. Scroll up a little bit, please. So boot disk, what do you have? You have under boot disk. Boot disk.
Boot is
Change that to Ubuntu. Yeah. We right now have Debian GNU. Just change that to Ubuntu 18.04. Pardon me. And also allow the HTTP traffic. Ubuntu. Yeah, I think 10 GB should be good. And allow HTTP traffic. Okay, good. You can create it. You can leave the defaults. And open up the Cloud Shell. Click on the Cloud Shell. It's on the top right-hand side.
yeah.
Okay. Oh, okay. Just type in gcloud compute or compute instances. Instances list. Mm-hmm. Zone is US4P, right?
Yes.
Okay, let's do gcloud compute SSH instance 1. Gcloud compute SSH instance 1. And give the zone -- zone SSH -- zone and copy paste the zone.
Enter.
Yes. Okay, so we are into it, and you can do a sudo apt get update. Sudo apt-get space update. Enter. So we're just preparing this machine with the latest, with some of the latest packages based on software. And we'll also try to install Apache 2 after this one. So just type in sudo apt-get install -y Apache 2. So we should be able to access that one. So now just figure out the public IP address of that. I think you have to go back to that one. Yeah, the Google Cloud Console. You can say authorize. You can open this one in a separate window so that you don't have to. Okay. Yeah. Copy that and access it. Let's see if you're able to. There you go. So the Apache is already started. Now come back to your window and check the status of sudo systemctl status Apache 2. Systemctl status Apache 2. Okay, it's active and running, and I think, let us say, just for the sake of discipline, go ahead and stop it. Now try to refresh the Apache web page. Refresh. Cool. We're just making sure we are hitting the right one. Now go back and start it again and verify it again. Pardon me. Okay, so I'll take the screen. I'll cover a few more slides.
Okay.
Thank you, Bernie. Let's bring this up. Okay. So again, the choice of compute, Google Cloud Engine, Google Kubernetes Engine. As we are moving from left-hand side to right-hand side, on the left-hand side, if we have a Google Compute Engine, our customizability, how much we can customize is more. Generally, when we are developing an application from scratch and we have a lot of customized requirements, we will start using the Google Compute Engine. That's where we need very high customization. As you move towards the right-hand side, the Kubernetes engine, that is where when the Kubernetes comes in, you take your application, you're plugging them into, you're kind of wrapping them around different kinds of containers and deploying them based on your application and other kinds of factors is what it is. So in other words, the customizability is slightly reducing as you move to the right-hand side, but they're being more managed. The manageability means manageability from the cloud providers standpoint is increasing, is what it is. App Engine is where we have generally, when we have a specific application already developed, that is what we generally deploy in App Engine directly. So Google Compute Engine is we are developing the application, but an App Engine is where there are a lot of applications which are already developed. They could have been developed by somebody else. You can directly install them. So in other words, you don't customize it, but you just install it on yours and then you try to use them. So the customization is slightly less and the manageability, because they are being, that could be part of the Google Cloud, or maybe some of their vendors may have developed that application and they have just released it for everybody to use, and maybe they will be charged and things like that. So the manageability, so behind the scenes, the managing part is being taken care of by the cloud provider. So we don't customize, we just use it as it is. Cloud Functions is again, we are only writing very, very specific functionality or features of the application of the code. And that part of the code, that could be a simple function, maybe a simple library, is getting deployed into it. So in other words, the server, the platform, the infrastructure, the platform, and the other kinds of things, dependencies, are being taken care of by the cloud provider. We only write the code. For example, we are writing some Python code or maybe some .NET code in the form of a function. You just write the code, and the dependencies based on this Python or .NET, we provide them. We upload them to a bucket or somewhere, and tell the cloud function or the Lambda function, it will automatically load these things. But behind the scenes, the server and the other kinds of maintenance of the server aspects, the infrastructure aspects of it is being taken care of by the cloud provider. So it is highly managed, but customization, we are not customizing those aspects of it. So the customizations is less. So as we are moving towards the right hand side, our manageability is more and customizability is less, is what it means. Is that making sense, Rahul? Are you understanding that?
Yes, but sir, what is the difference between this app engine and the cloud function?
Okay, so imagine, for the sake of simplicity, imagine you're developing an application from scratch for a finance department, or maybe for a billing department, or maybe HR department for a specific client. So you're doing everything from scratch. That is where we generally go to the Google Compute and we write the code right from line 1. Whereas App Engine is, maybe you can kind of think of it like this, a database. Imagine you're using an Oracle database or an SQL database. That is like an application or a program which is already written by Oracle, maybe Microsoft. What you're doing is you're directly installing it on your Google Cloud. So that is not written by you. You have already taken a program or a serious application which has been written, which has been developed. You can further customize that, but it is already written there. Whereas here, you imagine in Compute Engine, it's like you're coming up with your own idea of a database or maybe a separate application right from scratch. In such case, you will go to the Google Compute Engine. Catching it, Rahul?
Yes. So in App Engine, how we will just we need to upload the code and it will get hosted.
Ideally, in App Engine, you will not even, again, you can upload the code. If you're uploading the code, that is generally the Compute Engine. You are taking an application, you're installing it, and on top of it, you will add some additional code if it is necessary.
Okay.
I'll see if I can also give you a quick example of that in the coming up days, Rahul, just to clear your. Okay.
Okay, and in Cloud Function, we need to...
Cloud Functions is a Lambda function where you, when we use Google Cloud, Google Compute or Google App Engine, in Google Compute, you develop a full application. An application may have 10, maybe 20 screens, and they provide different kinds of features and functions. And in App Engine also, an application which already has a lot of features, pages, and things like that, we are using. Whereas when you come to Google Cloud Function, this is a scenario where you need only one specific feature. You don't need 20, tens and tens of features. You need one feature, which is if a particular file or an image has been uploaded to a particular directory or a bucket somewhere, you just want to read that data or maybe that image, you want to make a prediction. Is that a cat or a dog? Or maybe you just want to read the data in the file and predict if a stock is going to think. So that is just a single feature. What is that? That is the kind of scenarios you generally use the cloud functions or Lambda functions. Okay, so again, here are some use cases and things like that. So Google Compute Engine comes under infrastructure as service, virtual machines, highly customized workloads. So when we are creating our own virtual machines and things like that, we are indicating it is highly customizable. Kubernetes is again, Google Kubernetes is coming under container as service. So this is a new one, containers and microservices and things like that. So in microservices are nothing but your applications which are running. You can kind of run an application as a service inside a container, and container has all its benefits that we have seen about the fault tolerance replications and managing and orchestrating. They will automatically inherit all those things. So that is a container service, which is new one. It is referred as a containerized workloads. In other words, more precisely, today everybody is moving into the world of Kubernetes. When you touch Kubernetes, you're touching Docker. And if you're using Kubernetes and things like that, it is referred as a container as a service is what it is. So any of the applications when they are deployed, they're all trying to plug them into the Docker and the Kubernetes and install and deploy them into their environments and manage them because of the benefits they are providing. Because of the isolated environments, they don't impact other environments and things like that. It makes the life easy for both the developers and the operations team. So that is the Kubernetes, Google Kubernetes engine. App Engine, again, platform as service, it's managed runtime. So line of business, okay. So more precisely, you can, earlier I just referred Google Compute Engine as where we are developing the applications, whereas here it is actually referred as when you're creating the virtual machines, you're using Google Compute Engine. When you're actually writing the applications, that is App Engine. So in other words, in a moment back, I just gave you an example where you're writing from line 1 to line 100 or maybe line 10,000 and you're writing a big application. I referred that as Google Compute. That is actually coming under Google App Engine. But you can also ideally treat that as a Google Compute because in a way, but for the sake of simplicity, we'll put it back into Google App Engine. We'll call that as Google App Engine. And here, the virtual machine. So in other words, we are taking the platform as service. So the virtual machine is already there. Inside the virtual machine, we are writing an application. Whereas in Google Compute Engine, we are creating the virtual machine. So we have a little bit more customization. So that's why we are referring it to as highly customizable is what it is. And also what I said was, even if you were to take an existing database like an Oracle or a Microsoft SQL server, that can also be treated as a platform as service because there also the virtual machine is created to you. The application is already there. On top of it, you write a code. That can also be, that is also be treated as a platform as service. Cloud functions are again a new term, function as service. This is very event driven for specific tasks, for specific events. You want to, when that stock goes down, what you want to do. When this stock goes, any change happens, what is it? That is event driven. When you have such kind of requirements, we can use the Google Cloud Functions. Okay, Rahul, making sense?
Yes, sir.
Okay. So storage services, again, storage is nothing but the hard drives and things like that, storing the data. It can be divided into object storage, block storage, and file system. So block storage is where a file is being taken, it is being split into small parts. They are referred as blocks. Even if you take a traditional operating system, at an operating system level, even a small file is being split behind the scenes into very, very small blocks, 16 KB and things like that, and stored across the hard drive and things like that. That is block storage. Object storage, one moment, please. Rahul and team, just give me a 5 minute. I just need to step out for one moment, guys. Could you please take a 5-minute break and regroup, please? Sorry about that.
Okay.
Okay. Rahul, are you back, buddy?
Yes.
Are you back, Rahul?
Yes, sir.
Okay, sorry about that. Okay, storage is again about storing, different kinds of storage and so on. Object storage is different kinds of objects, unstructured data and things like that, the images, the videos and things like that. File system is just the regular files and so on, guys, okay? So storage services can be used to store unstructured data. Unstructured data is something but nothing but your videos, image, the textual data is generally referred as unstructured data. Folders and files, we are generally in the world of folders and files is what it is. So unified object storage for a variety of applications means it's a single place where we can store different kinds of data. If you have unstructured data, structured data is generally the data in the database, the files, folders, and can also be stored in one place. That is what they mean by unified storage. Applications can store and retrieve objects through single API. So in other words, this is nothing but the Amazon S3. This is the S3 of Google is what you can say. It can scale to exabytes of data. Again, that is just like S3, no matter how big it is. Exabytes is really, really big, guys, unless you're working for NASA's and Yahoo's and Facebook's, which generally, or something related to space, spatial science and things like that. We don't really touch exabytes of data, but we can really save some larger amounts of data and files here. It is designed for 99.999, so that's about 6 nines or maybe 9 nines durability, which means there is a very, very less percentage of file or a folder or any object or any other image becoming unavailable or not available when we store into the GCS. It can be used to store high frequency and low frequency access of data. High frequency means very frequently we are accessing, that is generally the data in the database. You have an application where you're storing the data, you're modifying the data constantly, you're updating it, deleting it. That is high frequency. Low frequency is like archival data. You access it very, very rarely, maybe a week, a month, or maybe a year. That is low frequency of data. Both of them, both the kinds of data can be used for storing in Google Cloud Storage. Data can be stored within a region, dual region, or multiple region. It also gives us options, which we will see, where it will tell us, hey, do you want to replicate this across multiple regions or maybe only in a single region and so on. Rahul, okay, buddy?
Yes.
Okay, so there is high frequency. The standard comes under standard model. Most common storage access used by developers. It is optimized for reduced latency, which means when you store the data in the database, generally when an application tries to access the data, it should not take a long time. It should you should try to retrieve the data quickly. That is what is low latency. It should not take a long time. That is the high frequency. You're not only accessing it many times, but when you access it, you want it to access it very quickly. Low frequency is also referred as nearline and near real time. No, this is not near real time. Nearline, okay. It is meant for data accessed less frequently. For example, something which is accessed in a month. So maybe imagine a bank where they are storing the monthly bills of all the customers, and they are not frequently accessed. They're just accessed once a month, maybe once a year, on a need-to basis and things like that. That can be an example of a low frequency data. So lowest frequency is where you're accessing once a year. And that is maybe for the yearly budget and things like that, you need some data to be accessed once a year. That is the lowest frequency of data. That is called cold data. So we have cold, warm, and hot data. So the standard, the high frequency is the hot data. Low frequency is actually between warm and cold. Warm is a little bit more high frequency. And then you have the cold data, which is very, very rarely accessed, guys, okay? Persistent disks provide reliable block storage for the virtual machine. So in other words, these are nothing but the disks of the volumes, additional volumes that we add. Sometimes when we create a virtual machine, for us maybe 1 terabyte or maybe 2 terabytes is enough. But when we need some additional data, we may want to plug in additional volumes, additional drives and things like that. That is what is a persistent disk. And they're independent of the compute engines. So when you create a virtual machine, you can separately install the additional storage, is what it means. Each disk can be up to 64 terabytes in size, and that is customizable. PDs can have one writer and multiple readers. That is a slightly advanced scenario. When we are working with some high frequency data, in certain applications where the data or the database itself is replicated across multiple regions, multiple servers and things like that, and they need a very high frequency and a very high consistency where they cannot afford the data to be out of sync and things like that. So one server will be used for writing the data to the database, which is sitting across multiple servers. And behind the scenes, that particular database will be syncing up with many other. Let me see if I can give you a quick example here, just to give you an idea. Sharing it. Snap it. Put this in. So this may be slightly useful for you guys here and there. So here is an application storing the data, and before that we have, here is, let's say, a server 1, and let's say here is another server 2, server 3, server 4, and so on. So now what happens is, visualize, you have a database here. The same database is also sitting on these servers, which is replicated. So in other words, all of these are copies of the same database. But what happens is, at the time of writing this data, at the time if somebody is modifying or adding some data, it will not be written to these servers. It will be only written to this one. Behind the scenes, this will send a message and sync up here, saying that, hey, I have received an additional row, or maybe a modification of a row. So sync up, sync up, sync up is what it is. So what is that? That is, we have one writer and multiple readers. In other words, when this application is writing the data, this is the process how it goes. But when it reads the data, what can happen is, it can read it from here. It can read it from here. Sorry, let me put the reverse. It can read it from here. It can read it from here, from here, from here. Ideally, what will happen is, just visualize another kind of a load balancer or something which is between the application server, and this is acting like a load balancer. The load balancer, or maybe like a gateway, which is deciding whether it needs to be sent to this database, or if you're making modification. And if it's a read request, again, the load balancer will not make that. It will be at a slightly more low level, but generally we will have another kind of a load balancer which is used for balancing the requests across these things. But at a high level, that is what one writer and multiple readers. It is for very high performing applications where you need the speed and the things like that. If you're dealing with stock data at a very seconds level, or maybe milliseconds level and things like that, and you're using a very heavy NoSQL database and things like that, in such cases, we come across one writer and multiple reads. There are other ways of designing the applications, and but that's just a quick idea, guys. We don't need to go into those details, but you need to have at least a little bit of idea. That's why I'm explaining that one. It supports both SSD and HDD storage. So SSD is slightly faster than HDD. SSD offers best throughput for IO intensive applications. So again, short and sweet, SSD is much more faster. You guys might be already familiar with it. And it is available in 3 storage types. So you can use the persistent disk in a zone, in a region, or in a specific local, which is maybe a group of regions, I think so, guys. Okay. So we'll try to see that. Google Cloud File Store. So this is like your file system itself, managed file storage service for applications. In other words, The Google manages this one. They're giving you like a file server, which is referred as a file store. So it delivers NAS-like file system interface and a shared file system. So it looks like as if a drive which is mapped on another server or on your machine is what it is, and you access the files as if they are just an additional drive on your own machine, guys. Okay. Centralized, highly available file system for GC and GKE. So again, in other words, behind the scenes, this file store is used by the compute engine and the Kubernetes engine a lot. Exposed as an NFS file share with fixed export settings and default Unix permissions. So it has Unix-like permissions, the read, write, and execute permissions. File store file shares are available as mount points in GCVM. So again, mount points is nothing but they are just acting like an additional drive or an additional folder that you just you use them as if they are part of the local computer. So on-prem applications, on-premises applications using NAS take advantage of file store. Again, you're using it as part of your on-premises server, where your application or we ourselves as users are using these file stores as file servers. File store has built-in zonal storage redundancy for data availability. We'll try to understand that, guys. So at the time of creating a bucket or a folder or maybe a file or something, it will say, hey, do you want to replicate this across multiple zones or multiple regions? That is what it is. Data is always encrypted while in transit. In other words, pardon me, if at all we happen to upload some data, that data is at rest. Once the upload is complete, it is at rest, it is encrypted. While you're uploading also, what Google does is it encrypts the data and then it uploads it so that if any of the, maybe hackers or maybe somebody who's snooping into networks and looking and things like that, they will not be able to retrieve the data and they will not be able to understand what is the data. So that is the data in transit. While you're uploading also, the streams of data is being encrypted and saved back to the actual server is what it is. Rahul, okay, buddy? Is it making sense?
Yes.
Okay. Okay, let's see. Let's see if we can take an example here. Can you share your screen, buddy?
Yes.
Okay. Back to Google Cloud Console. Let's create a bucket. Just type in maybe storage. You can type in a bucket also. Yeah, cloud storage. Okay, create a bucket. And you can give any name. Okay. You can, yeah. If you'd like to, this is where we can store it in multiple regions, dual region and region. So if it's multiple region, it's slightly more expensive because the multiple copies are getting saved. And here, I think we can just choose a single region. Dual region is just 2 regions, right? And so they're kind of giving a slight another option. And I think US West or something like that, I think was where, but you can choose anything. You can choose US, what is that? Southeast Asia or something like that, if you want to. That should not be a problem. And let's say, imagine default storage. Click on nearline. Click on nearline. Cold line. Okay. Imagine you were to store an image object. Do you think that is a high frequency data or a warm frequency or a cold frequency data? Rahul, what do you think it is according to you? Imagine you're storing an image in the Google Cloud or maybe in the cloud. Do you think it is constantly accessed or is it like a?
It depends whether if it gets frequently accessed, we can store it in a standard.
Good answer. It's a very practical answer. So more precisely, it could be hot, cold, or warm. So that really depends on the requirement. If it could be maybe an Excel list of all the stocks data and things like that. That is also that is generally high frequency data. But here you can choose standard, kind of like a hot frequency data. Then choose how to control the access to objects. Let's see what we have there. Enforce public access. Public access prevention on the bucket and uniform. You can, I think, leave it as uniform.
Okay.
And choose how to protect object data. Scroll down. Object version. No, I think you can leave this as just default created. Stay taken. So just give some other name. Okay, I think that's globally unified, unique bucket, I think is what is. You can upload the files, folders, and things like that. And let's see. Is that it? Say create folder. Just click on create folder. Just give some name, images. Then go to open a new browser and go to images.google.com. Just download some image. Images.google.com. Just type in nature. Nature. Yeah. Download this. Maybe download the first image or whatever you like. And then upload it to the bucket. So again, this is similar to how we are creating buckets in Amazon S3 and things like that. So this is a scenario where whenever somebody uploads a file or some kind of data here, generally, you may want to treat that as a trigger to run some cloud functions and things like that. Is a common scenario is what it is. Whenever you want certain event to happen, application developers may use this. They'll just trigger a cloud function by uploading a file, maybe some kind of a data and things like that. Is one common practice. So just click on configuration, permission, protection, lifecycle. Just click on those tabs there just to get a feel of them. Again, based on your needs and things like that, you can modify them. I think somewhere here, there is it also gives us a geo replication. Just replication is nothing here. Just public access status. Okay. Okay, that's okay. Somewhere I remember seeing a geo replication.
Replication is
I don't remember seeing the time of creating a bucket, but we'll be creating a few more. Nothing to worry now. Just click on permission. Not public. I think this is where we can also go ahead and open it to the public and things like that. If it is a free one and things like that, should be able to configure it. But okay, principals, roles. Okay. Scroll up, please. We'll talk about principals, roles in coming up days.
okay.
Then protection lifecycle. Just a quick look. I don't need to go into the details. So version. Do you want to version it or not? And I think default event-based hold option. Okay. Okay. Haven't really looked much into it. Then the next one, lifecycle. Let's see. Add a rule, delete or delete. Deletion takes precedence. Okay. So I think these rules will trigger some other things and so on. I think I have not really used it that much. Generally, we just upload the files and things like that. You write an application. In that application, you're reading the data. You're just modifying it and things like that is generally what you do. Is what it is. Okay, buddy.
Yes. Yes.
Okay. I come back here. Okay, I'm going to share my screen for 1 minute. Okay, so GCP service use cases, cloud storage. Storage type is object storage. This is scalable, durable, and long-term storage. And centralized storage for frequently and infrequently accessed files is what we are referring as the use case. Block storage is a persistent disk attached to GCE VMs, dedicated attached storage for apps running in virtual machines based on hard drives and solid state drives. Cloud file store, it's acting like a NFS file share and a NAS-like file storage. So in other words, again, this is file storage for files and things like that. If you need more storage, you use persistent disk. Google Cloud Storage is for unstructured data and other kinds of data. That is again used on long-term basis and so on. Some use cases. Okay. So quick look at network services. Network services are one of the key building blocks of cloud. GCP leverages Google's global network for connectivity. So short and sweet, they are physically connected all over the world and things like that. They have global physical network connectivity. Ideally, whether we are using AWS, GCP, or Openstack and things like that, many times we are creating virtual networks, private networks, public networks. Public is when you want to give external access. By default, all of them are private. They're all internal within the cloud context, guys. Okay. So they do have the physical connectivity all over the world. Customers can choose between standard and premium tiers. The more higher you go, the more the cost, the more the premium it is. Virtual private cloud offers private and hybrid networking. So private is just within the organization. Hybrid is a combination of private and a public, can be referred as the hybrid networking. And there are again different kinds of security groups and rules that we generally use and configure to give access using through the ports and things like that. So customers can extend their data center to GCP through hybrid connectivity. So in other words, if a customer has already set up a on-premises data center and on top of it, they want to make use of a public cloud. So they are not only using private, but they're also using certain features of public. Generally, what happens, guys? All the data, the storage, what the client, for example, the financial organizations, the data part of it, you want to keep it private. The compute part of it, you can keep that as public. So at the time of reading the data, you read the data and you send the data to the compute. When the data is sent to the compute, it is there in the RAM, nobody is able to access it. If it is there in the hard drive, you can access it. So what do? The hard drive, you keep it in the private cloud. And at the time of computation, because it is much more cheaper on the public, you send the processing to the public cloud, have the processing done there. And then when you get the results, you will again persist or store it back in your private cloud. So we're getting the best of both the worlds, the private and the public. That is what is hybrid. So again, we can configure the network so it allows us to configure the network for hybrid connectivity. That is what it means. Making sense, Rahul?
Yes, sir.
Okay, network service tiers provide a choice of traffic optimization. There are two service tiers, Premier and Standard, again, the same thing. Premium tier delivers traffic via Google's premium backbone, more expensive, short and sweet. Standard tier uses regular connectivity based on ISP networks, slightly less expensive. So GCP uses premium tier as the default option. So it looks like they're giving us by default, the premium network, which is why it is premium and which is expensive. Then again, we have Google Cloud and load balancing. This is nothing but the load balancing part of it, where a single application may be getting a lot of requests. So many times we can replicate this application and have the request balance across multiple servers rather than only a single server. That is what is the main functionality of the load balancing. It is balancing the load of requests is what it is. So it is distributing the traffic across multiple VMs in a single or a multiple region. And there are two types of GCP load balancers, HTTPS and network load balancer. We can think of HTTPS as the external load balancer, network load balancer is the internal load balancer. So we'll try to look at a quick look. Generally in a scenario where we have a web server, a database and a UI server, the UI is where the browser is where the external world or people around the world are accessing our application. So we need to have a HTTP load balancer between the UI and the web server. And between the web server and the database, we can have a internal load balancer that is referred as the network load balancer. So HTTP load balancer provides global load balancing. So which is again external load. It is also taking the external load. Network load balancer balances regional TCP and UDP traffic, which is generally internal traffic. And both types can be configured as internal or external load balancers. Do you have an idea of internal and external load balancing, Rahul?
We mostly use that external load balancer. I don't have more idea about that internal.
Oh, okay, so here is an example. I think let's say, maybe see if I can use this one. Okay, so what we have is external load balancing. There are different kinds of users here. This guy is from San Francisco. He's using a mobile phone. Another one from Iowa. And this could be a browser also. It need not necessarily be a mobile, and there could be other kinds of interfaces, maybe a tablet, maybe a laptop and things like that. So what these guys are doing is all of them are accessing an application. And what this is doing is this is a load balancer which is going to distribute the traffic. Generally, what we will have is we will have something like this, guys. Imagine the web tier. This is a web tier. And imagine this is like a single database. Let me put the database here. So without load balancing, all these requests are going here to this server behind the scenes, and all these are being processed. They're accessing the database, they're getting the data. Once the computing or the processing is done, they're returning the data here. The results are being returned here. So what will happen is when the number of users are in millions and millions at times and things like that, when it's festival time, you're accessing an e-commerce application, and hundreds and maybe thousands and maybe millions of people are accessing certain deals, the iPhone deals, or whatever those deals are. What will happen is the traffic is so much that this server will not be able to handle it. So that is where the load balancer is coming in. So now what this load balancer is doing is it's allowing the external traffic to come inside. Before this one, it was the web server which was actually opened up, and it was put in the maybe a demilitarized zone, DMZ. D is probably, I think, what they refer to in terms of networking. So now it is not the application, it is load balancer which is sitting in the DMZ, and this we are having multiple servers, or a single server can also have multiple instances, or maybe the same server is replicated. And inside each server, so we are maintaining 3 servers. So what the load balancer does is the first one goes here, the second one goes here, third one goes here. So by the time the third one is completed processing, this will free up. By the time this is taken, this will free up. And as a result of that, we are getting a much more faster processing. So more precisely, the most important thing what I'm referring is the external load balancing is it's accepting the traffic from the internet. And again, between the web server and the database, there is another load balancer. Sometimes a single database, if you just maintain a single database, that might get overloaded too. So you maintain multiple replicas. In enterprises, you try to maintain multiple replicas, and you maintain another internal load balancer. This is not exposed to the outside world. This is only within inside. That is what is internal load balancing. It is doing the load balancing internally within the private network, whereas this is exposed to the public also. That's why we're referring it as external. Making sense, Rahul?
But sir, this internal load balancer used for this backend servers, like we have three-tier architecture. We have front end, backend, and database.
True.
So, I heard that the internal load balancer mostly used for that backend servers, and database servers we don't use load balancer for database.
No. For complex applications where you need multiple replicas of the database and things like that, you will use internal load balancing. That's
Okay.
a common practice, yeah. If it's a simple application, you probably don't need. This is probably an overkill. Most of the times, as you said, it is only a single database. But for some complex, as the complexity increases, as the number of requests to your database is increasing, that is when they will try to maintain multiple copies of your database. And that's where we can do the internal load balancing. As simple.
In this diagram, they is showing the internal tier, and these are the backend server, right?
The web tier, the database tier, these are all the tiers which are generally inside a server. The white box can be thought of as server. Again, you can think of that as server. You can also think of each box itself as server. In this server, this is exposed, this port is exposed, or in other words, let me see if I can clean this up a little bit. Let's see.
I thought this that internal tier is kind of backend server and web tier is a front end server. And database tier is our data.
One moment, please. Okay. So in other words, you can have this whole thing in one server. That is one architecture, or just the database itself is sitting in one box, and just the load balancing is sitting in one box, and just this one is sitting in one box. This is sitting in one box. You can also architect in such way. It really depends on the high level requests of how many requests you're expecting and things like that. Catching the point, Rahul?
Yes.
You can generally discuss with your own architect and try to come up and see what they think and why they think it might be necessary to have multiple tiers and multiple servers like that. Okay. So a little bit about VPC is a software-defined networking, providing private networking for VMs. So in other words, the VPC is again a SDN. Providing networking for VMs. It's taking care of the networking aspect of it. VPC network is a global resource with regional subnets. Again, short and sweet, a network may have a group of networks. Those are referred as subnets. Each VPC is logically isolated from each other. So in other words, one VPC, one client, one VPC, another client, another VPC. So they are isolated. This client will not be able to access that one unless we have specific rules configured. That is what is the firewall rules allow or restrict traffic within the subnets. Again, if you recall how we create the security groups and things like that, I think all those things come under those rules in AWS. Resources within a VPC communicate via IPv4 addresses. Again, we use the IP addresses and things like that. VPC networks can be connected to other VPC networks through VPC peering. VPC peering is again a pair of virtual private clouds where sometimes we need to be able to access certain resources from other cloud. I'm not really a big expert in that aspect of it, but that is what is peering. VPC networks are securely connected in hybrid environments using Cloud VPN or Cloud Interconnect. So in other words, those are acting like a bridge between multiple VPCs networks, VPN and Cloud Interconnect. So I'm sure you guys are familiar with the virtual private network, but they are acting as a bridge between wherever you are to your virtual private cloud. Making sense, Rahul?
Yes.
Okay, let's see what we have. Okay, let's quickly take one more and see what I have here. Oh, I think this is a slightly deep one here. I want to save this for tomorrow. I want to save one lab for tomorrow because this will take may take a little bit of time. Let me see if I can move on to another topic. That's a big one. Okay, so let me just take a little bit of more theory for today, because the load balancing is the next one I wanted to show you, but that is slightly time consuming. And I don't want to extend that one today. So there it is. So network services, HTTP load balancing, we just discussed about it. It is global load balancing. You are allowing the external access. CMS deployed in multiple regions. So in other words, CMS is like an application. For example, your Openstack, just in case you're also dealing with that one, can also be thought of as a content management system at a cloud level, at a cloud-based level for sharing the compute, storage, and networking resources. CMS means content management system. So that is an OpenStack. For example, you may have installed OpenStack at your company. You go home to another location and you're trying to access it. So what is happening is you're accessing your application from outside. So what is that? That is external access. What is that? That is what is where the HTTP load balancing comes into. And now you might be in at your home, or you might be in another country or another part of the world or the continent. In such region, in such cases also, we can have access to other parts of the world. So that is what is deployed in multiple regions means. TCP load balancing is generally for the internal traffic. So regional load balancing of TCP or UDP endpoints, or distribute traffic evenly across gaming backends. So in other words, imagine a very high performing gaming application. So what they're doing is anything they do in the gaming, a lot of processing is happening behind the scenes. So they take the request, all the processing, they don't do it on the person who's playing the game. They take that request, they send it to somewhere in the backend where they maintain some heavyweight servers, and they do the processing there, they return the results back to him. So they're just sending the request and having the processing being done at behind the scenes. And behind the scenes, what is happening is the backend load balancer is taking it and distributing it. Why? Because if a game is being played by millions and millions of users, that's exactly where we need the load balancing come into picture, and auto scaling, all those things also need to happen, guys. Okay. So VPC is nothing but private networking, virtual private cloud, and it's a private networking within the cloud. And deploy GC VMs that are not exposed to the public internet. So this is only within the organization, within the enterprise. We want to use these virtual machines. That's where we need the virtual private cloud. Interconnect dedicated network to external local data center. So access cloud resources from local applications with low latency, which means you have an on-premises data center, and you have where you're maintaining a private cloud. Now, as I said, you're storing all the data here because data is very sensitive and highly confidential. You store the data here. But at the time of computing, you want to make use of the cloud. That's where you can ship the data. Part of the data that you need to be processed can be shipped to the public cloud. And the processing will be done in the public cloud and will be returned back. So that's where the interconnect is acting like a bridge between your on-premises data center and the cloud data center is interconnect. Okay. Then VPN, secure access to GCP resources through public internet. Again, it is cheaper option to extend local data center to the cloud. So for example, when you're accessing your OpenStack and things like that, you guys are using the VPN, you enter the username, password, the tokens and things like that. And it's kind of creating a private network from your computer to the thing, and no other traffic will pass through this one. So it's also like a bridge, which is restricting any other access. It doesn't allow outside access, nor will it send the data from within the network to the outside network. This cloud VPN. Peering directly access cloud resources with reduced egress fee. Egress is nothing but outbound is egress, ingress is inbound. So secure access to GCP and G Suite resources via direct or carrier peering. So that's a slightly deep one. So in other words, G Suite is, the Google suite of applications. It's the Google's PowerPoint, Google's Excel spreadsheets, and other kinds of services. There are lots of other services which are generally used as part of the GCP. So again, I don't have a very, very good example for peering, but generally, when you're sharing these resources as part of your, so you're not purchasing these things, purchasing the softwares, but you're using those softwares, and those softwares are there on the network, on the private network, but they actually look like they are on your network. So you're kind of sharing it, and that is what is peering, is my understanding, guys. Okay, Rahul, catching it, buddy? Okay. Okay, I am again a pretty familiar one, the identity management and controls access by who, what, your users, roles, permissions, and things like that. Cloud IAM is based on the principles of the least privilege. So an IAM policy binds identity to roles which contains permission. So again, we have a user belongs to a role. A role can have multiple permissions. Permissions are read, write, and access, execute access. Roles is where maybe you're defining a role for maybe a separate role for a finance department, a HR department, a billing department you're creating. And each of those people who are working in those will become the users, is what it is. So principle of least privilege is what I'm trying to kind of recall. So there it is, identity and access management. We'll see this, maybe we'll see it tomorrow. So policy is again a group of customized settings that we want certain services to be made available based on certain roles and permissions. So we define a policy, is what it is. So let's say, so here is an example of different users and members. Google account, then you have a service account. Google account is what you open in using your username. Service account is based on the service. Compute service may have its own account, its own endpoint and things like that. Google Groups is groups. G Suite domain is Google suite of applications. Then cloud identity domain. I don't recall what that is, guys, pardon me, but I'll give me a few. All authenticated users are the people who have access, who have a Google account and they are logged in. You might be anywhere in the world. If you have a Google account and you're logged in, you're authenticated by the Google. So there are some applications or maybe some features or parts of the application. If somebody is logged into Google, in other words, if they have a Google account, you want to give them access. So these days you go to any website, they'll ask you to open a new account and they'll give you this Google option also, Google account option also. So why behind the scenes Google they can access who, they can get your details from the Google and try to understand if you are going to be their possible customer or not and things like that. All users is anybody and everybody, all the users around the world. Authenticated is you definitely have a Google account and you are logged into the Google, is what is authenticated users, guys. Okay, so I am permissions. Pardon me, I just have a few here and I will leave you for today. Tomorrow we'll start with a little lab and things like that. So bear with me, guys. Permissions determine the operations performed on a resource. So permissions, there can be any kinds of permissions. At a local computer level, we are only referring to read, write, and execute. But when you go into IAM and things like that, based on the resources that we are using, we can, there are a lot of inbuilt permissions which are created by Google. And we generally use this thing, whether you're an administrator, whether you need a read-only access and things like that. And correspond one-to-one with REST methods of GCP resources. So in other words, REST methods means representational state transfer. It's a way of accessing the data in the form of endpoints and things like that. All the resources can be accessed as web services or services. And we are associating permissions with these methods or services is what it is, to put it in a simple way. Let's see if I can simplify it. Each GCP resource exposes REST APIs to perform operations. So when so here is an example, publisher.publish. Behind the scenes, when you say publisher is a service in which there is a method or a function called publish, behind the scenes it is calling pubsub.topics.publish, or in other words, that is the method it is calling, it is being hidden. We are being asked, if you want to publish means you are publishing some message saying that you have something or an application ideally is publishing something, as you don't publish it. Within an application, something happened. And there are different servers it wants to broadcast and say, hey, something happened here. It could be good, it could be medium, or it could be bad and things like that. So what do? You publish it. When you publish it, behind the scenes, this publish method is getting called. How? And what is this? This is REST-based access, being able to provide this kind of a, you'll give something like http/v1/publish, publisher.publish, that kind of a, you can also say publish/1/2/3. That is generally referred as representative state transfer. And that is an API. Since you're able to allow, since you're allowing your resource to be accessed as a API call, as a programming interface, application programming interface, that is referred as a REST API. And for them, sometimes these things can be given different kinds of permissions. So permissions cannot be assigned directly to members or users. One or more permissions are assigned to the role. So when you have a group of permissions you need to be done, rather than directly assigning it to the user, you create a role. At a simplistic level, maybe if you take a CEO of a company may be able to have complete access to the finance department, billing department, and maybe the HR department. Whereas if you're only belonging, if a person is belonging to the HR department, you will not be given access to the finance and the billing department, but you will only be given access to the HR department. So what is happening is a group of permissions, a group of rules are being formed here. What is it? That is what a group of permissions are being treated as a role here. One or more permissions are assigned to a role, means a group of permissions are being designed as a and treated as a role is one way to think of it. So here is what it is, guys. A more realistic example. By default, the primitive roles is what the cloud is providing. The owner is the guy who created it. Editor is somebody whom, imagine Rahul has created a folder. He's the owner. Now, who can edit it? Edit is, you may want to add a file. Maybe you may want to delete a file. That is an editor. You may want another person, maybe Ganesh, to edit it. But you may not want another person. Let's see, who do we have here? Just for the sake of simplicity, Srishal, you just want him to view it, but you don't want him to make any modifications. That is a viewer. These are primitive rules. For most of the resources, you can, the Google Cloud provides the primitive rules. Then these are the predefined rules. Again, this is for the compute, the storage, and the publish and subscribe is another service, is what it looks like. Custom roles is something where you design it based on your own application. You may want to come up with a new set of permissions and things like that, not just read, write, execute, but some other kind of thing. They are fine-grained and they're customized. Those are what is customized roles. They are like a group of roles, group of permissions is what it is, guys. Okay. Let's see. So here are the resources, projects, your buckets, compute engines are your resources. So it looks like in permissions we have consume, insert, and I haven't really digged much into those. But in roles you have start, stop, and delete. You want to stop these things, or you want certain users to be able to start them, stop them, and delete them. Those are roles. And again, users are Google account groups. These are the things which we just looked at a moment back, guys. Okay. So for today, I will stop it here, guys. I also need to get back onto another one. Tomorrow, we'll regroup and we'll try to play around with a few labs and continue the journey, guys. Everybody okay with that?
Okay.
Yeah. So signing off for today, guys. Any questions we'll take up tomorrow. I need to get on to another one. You guys take care and stay safe. Thank you, guys.
Okay. Thank you, sir.
Rahul, can you just check up your connectivity with Openstack? I think I was able to connect, so just you should also be able to connect.
Yes, sir. Yes.
Just maybe if you can double check and be ready, I'll cover a few topics in Openstack also.
Okay.
Thank you, buddy. Take care. Thank you.
Thank you.